Welcome to the 8.4 notes. We're going to get started with the warm-up here. Feel free to pause it anytime to practice the steps yourself. All right, so we want to find the area around the trampoline. So the part that would be the covering. So right around here. So what we can do is take the area of the dodecagon minus the area of the octagon. So these are both regular polygons. So we can start with area of the decagon, area equals 1/2 PA. So we've got 1/2 perimeter. So it's going to be 7 by 12. And then times the apothem. So the apothem of the dodecagon is going to be that longer line, 13 feet. 1/2, oops. So this ends up being the perimeter. And then this is the apothem, height of the triangle. All right, so then we're going to subtract the area of the octagon, 1/2 PA. So perimeter of the octagon would be 8.2 times 8 sides. And then times the apothem was 10. All right, so from there, just simplify. So you can use a calculator. Feel free to pause this again to multiply all these numbers together. So we can go 7 times 12, 1/2, times 84, times 13, minus 1/2. 8.2 times 8 would be, or actually I did 8 times 10 first because that was easier. 8.2 and then times 80. And then just simplify it out. So we get 546 minus 328. And then make sure you're labeling your answer. So it should be 218 square feet. So that's the area of the safety foam that you would need for your trampoline. All right, that type of problem should have been review. Number 2 says find the exact and approximate values of the shaded region. So this is very similar to the one we just did, only we're dealing with circles on this one. Okay. So we can take area of the big circle, pi r squared, minus area of the small circle. And then just fill in what your radius is. Sometimes this will be written like with a capital R for the bigger circle and a smaller r for the small, lowercase r for the small circle. All right, so it says the radius of the larger circle is 9. So that's what we'll fill in for the capital A there. Pi 9 squared, and then the radius of the smaller circle is 4. And then on your homework, I think I asked you to leave it in terms of pi and, so exact in terms of pi, and then also as a decimal. So the exact would say area equals, and then we can take 81 pi minus 16 pi. You can just subtract them just like you would subtract 81x minus 16x. Same thing here, it's just that pi stays put. So 81 minus 16 would be 65 pi. And then it didn't give us a label, so we're going to put square units. And then we can say area is approximately, so now use your calculator, 204.2 square units. All right, as we move on to the lesson here, 2 of these we've already done. So the annulus, the third one right here, that was the one that we just did up above. If you think of like a donut or a tire, you're trying to find the area between 2 circles. They've got to be concentric circles that they have the same radius or same center. And then sector of a circle, that's what we worked on yesterday. And then we've got this middle one here is the one that we haven't done yet. But we'll go ahead and review a sector of a circle again. So to find the sector of a circle, think of it as like a piece of pie. So if you want to find the area of a pi, you're going to use that pi r squared. But then we're going to multiply that times what portion of the circle are we dealing with. So some of you may be able to look at this and think 95 degrees is half of, or 45 degrees is half of 90. And you can just say, okay, 90 was a fourth, so 45 degrees must be an eighth. Or if you're not sure, you can always just put 45 over the whole 360. All right, so this time, since our radius is 20, we can go ahead and fill in that 20 for the r. So then we can simplify. All right, from there we can simplify 45 and 360. So I would just divide each of them by 45 to get 1/8. Okay, and then we still have pi times 20 squared. All right, so if we finish simplifying it, we can leave the 1/8 and change the 20 to 20 times 20. 2 times 2 is 4 with 2 zeros. So then on the right hand side here, all of this stuff that doesn't have a denominator would be over 1. So I'm going to go ahead and multiply my fractions. So it's like we have two fractions that can be multiplied. So now we've got 1 times pi times 400, 400 pi over 8 times 1, 8. So then we can take an 8 out of each of those. So if we go divide by 8, we're going to get, so 40 divided by 8 would be 5. 50 pi, what are we talking about here? Square centimeters, which is approximately, and then go ahead and calculate that. So take 50 times 2 pi, or 50 times pi, which would end up being approximately 157.08 square centimeters. All right, for the segment on the circle, this one's kind of the newer one here. So if you can kind of see, we've got a portion of a circle, so a fourth of a circle, and then we've got a triangle. So what we want to think of is taking this fourth of the circle minus that triangle to see what's left. So we've got radius of 6 on your fourth of a circle, and then on your triangle it's going to be a right triangle with 6 by 6. So I can think of the area equation, pi r squared, and then since I only want a fourth of it, I'm just going to take 1/4 pi r squared. And we can go minus area of a triangle, 1/2 base times height. So go ahead and fill in your numbers. And simplify. Feel free to pause it. Okay, 36 pi over 4 we can simplify it to be. 36 divided by 4 would be 9. So your area is 9 pi minus 36 minus 2. 9 pi minus 18, and then if we wanted to label that, we'd say square centimeters. And then if you did that on a calculator, 9 pi minus 18, you would get approximately 10.27 square centimeters. All right, the annulus is just like the one we did up above, problem number 2 there. All right, let's flip it over. All right, as we get example 4 started, we can see that this is very similar to the sector of the circle one, only we're missing the angle. So this time they gave us the area, so we can say the area is 14 pi. We don't know the degree of the angle, but we know the radius of the circle and the area of the circle, so we can figure that out. So what I'm going to do next is go ahead and put that pi 6 squared, maybe simplify the 6 squared, and then put it over 1, and then just multiply these over here. Multiply these straight across, so I can go 14 pi equals, so we have 36 pi x all over 360. Now there's a variety of ways to solve it from here. I'm doing it a little bit different than my online notes, so feel free to go look online if you want a different method of doing this. I'm just going to go ahead and put both sides, go ahead and put the 14 pi over 1 and then cross multiply. So from there I can take 14 pi times 360 equals 36 pi times x times 1, but you don't need the 1. So what we can do over here to get x by itself, we can divide by that 36 pi. So if I wanted to, I could simplify this left side, but a lot of stuff's going to simplify out nice. So instead of doing that, I'm going to just divide by that 36 pi. So if we divide both sides by 36 pi, on the right side, it all cancels. So you're just left with x, what we wanted to be left with. But on the left side, the 36 and the 360 can simplify just to be 10. 360 divided by 36. And then those pi's can cancel. So you have pi and pi. So you're left with on the top 14 times 10, or 140. So what does that mean? That is the angle, 140 degrees. All right, for example 5, you've got the bigger sector, so the outside part, minus the inside part, the smaller sector. So you can kind of look over here, we've got that circle with the radius of 5 and circle with the radius of 3. Now, since the angle they gave us was 120, we could subtract from 360 to find the leftover angle, 240. So I'm going to put my degree over 360 times the area of the circle. Pi r squared. I just did it backwards. And then we're going to subtract, the degree, 240 over 360, times radius squared times pi. Pi r squared. I just flipped it around again. All right, now if you knew that 240 was 2/3, you don't need to write it out. You can just simply write it. So if I divide both these by 12, 2/3 times 25 pi minus 2/3 times 9 pi, and then simplify from there. From there you can think of that 25 pi over 1 and 9 pi over 1 and simplify. So 2 times 25, 50 pi over 3. And then I'm just going to, even though I can simplify this one over here, I'm just going to leave it 18 pi over 3, because then we'll be able to subtract the numerators. So 50 pi minus 18, so 50 minus 20, that'd be 30. 32 pi over 3 would be the exact. And then the approximate, if we type that in a calculator, 33.51. And then again, we're talking area, so it should be square centimeters. All right, so if you've had a chance to read this, you'll see that we're trying to compare, find two answers, and see which one gives her more area. So feel free to pause it and try to figure out how I got them set up. From there, we can just simplify. So I'm going to go ahead and simplify them. So feel free to pause it, simplify them, and then we'll take a look at our answers and compare them. All right, so you see we take 1/6 of 400 pi, which would be 400 pi divided by 6. We can simplify to get 200 pi over 3 square feet, or 209.44 square feet. All right, if we double the angle, make it 120 degrees, if we simplify that, that would be 12 over 36. 1/3 times 100 pi, which is going to be 100 pi over 3. So then if I compare these, which is approximately 104.72 square feet, if I compare these, doubling the radius would give us a bigger area. So we're going to double the radius. All right, so you can see that, again, doubling the radius would give us a bigger area. So feel free to email if you have any questions on this lesson or some other homeworks.